I just plug my laptop and we can start. If I find... Okay, last thing, if I want to run that. Okay, so I'm Frank Pachot. I'm working at Yugabyte, which is a fork of Postgres to distribute Postgres to be able to scale out. Basically, we use the Postgres code for the SQL layer. And this talk is about PG int plan, an extension that I find very useful. It's not well accepted in the Postgres community that we need ints to force some execution plan, but we have an extension that we can use. It's quite useful. In Yugabyte, we install it by default because there is a lot of value. The main problem with it is that it's not very well documented, and many people just try it and have the impression that it doesn't really work just because there are a few pitfalls. So the goal of this talk is to really give you all the right information to get it working exactly as you want. Meaning the goal is that you want an execution plan for many reasons, and with ints you can have it if you do it correctly. So quickly, the reason why we may want to use PGInt plan to force an execution plan, I will take an analogy. If you go to Google Map, because a query planner is exactly like Google Map, the query planner tries to find the best path to your data, like Google Map will try to show you the best path to place. Sorry, the pointer just not working on the screen. Let me move it so that I can show you. Should be better here, yeah. So for example, if I want to go from the train station to here, I can ask Google Map, and the blue path is the best one. And the query planner does the same. It finds the best plan and just executes it. But you can see that Google Map gives you more possibilities. You can choose different transport methods. You can also have more options about how you want to use it. And you can even take a point and say, no, I don't want to go on this way. And PGInt plan is exactly the same idea. The query planner will come with an execution plan, but you have the possibility to change something for many reasons, just to understand the decision, to see what if this index is used, or just because you are on a bug in the query planner, the bad execution plan, long response time, and then you want to fix something quickly in the in production. So basically, you need this control. Not for all queries, of course, but at some point to troubleshoot something. And to do it correctly, then you need to understand how it works. So first, why do we need ints to control the execution plan? Because the SQL language is a declarative language. In SQL, you just describe the result that you want without telling the database how to go there to get the data. Then the query planner will parse your query and look in the catalog at the available access path, the indexes, the join methods, and then we'll come with the best way to access the data. But you may want to understand this choice from the query planner, or you may just want to work around a bad choice for some reasons. And this is where you can influence the query planner to choose a different execution plan. Also, there are some cases where the The query planner just doesn't know your data as much as you know it, and then may take bad decision. If you join many tables, then the estimation of the number of rows may be way off. So how to do it in Postgres with this extension? This is the picture of the Postgres community when you say, oh, we need ints. Usually, there is a wiki page with many reasons why we don't need it. I mean, it is harmless if you install it. Doesn't mean that you have to put ints in all your queries. It's just a tool that can be useful like any troubleshooting tool. How to install it? Just to look at the documentation, this is very well documented. This is just an example where I built a Docker image with pginplan install. I will not explain more about installing because this is well documented. Using it is not so well documented, and then we will look at it and have a small demo on it. So first, the ints that you put in your query are put as comments. So with a /* and then the int. And the reason for that is just because it cannot be part of the SQL language because the SQL language is declarative. You cannot have in the SQL language something that tells the database how to get to the data. And if it is not in the language, it is put as a command, a special command with a plus sign. So those are examples of ints. And here I'm just showing a multi-statement command to show you that it is at the beginning of it. I will explain the why. So it's quite easy if you understand a few things, how to put the ints, and also that you probably never need only one int, and that's the main mistake that can be done when using ints. So where do you put this command? The easiest is to put it in front of the statement, at the beginning of the command. You can put it a bit later if there is nothing else than those characters in it. So if you don't want to remember, then that's easier to put it just at the beginning. Usually, I put it before the select, for example, but if I explain, I just leave it there because explain and the option of explains are there. So we will see examples, but put it at the beginning, not anywhere in the statement, because if it is not parsed, it is just not used. Also, as a comment, but with a /*, not with --, that's different from Oracle. Some of this is common with Oracle because it has been done in the same spirit, but the usage is different. If you use prepared statement, you prepare the statement. This is where you have your SQL text, and then you execute it. The ints go with the prepare because this is where the query planner will look at it. And if you have many statements separated with a semicolon, so a multi-statement command, you must know that the int in front of it will concern all of them. That can be quite tricky, especially if you run on PSQL. You have to escape the semicolon, because if not, in PSQL, it will be multiple commands. So those things are quite tricky. Just remember how it works and come to that if you see that int is not used. If you use int correctly, you should see in the execution plan that it is used. So ints will, in many cases, reference tables or subqueries in the query. They reference not the table name, but the alias, because you may have multiple tables in your SQL statement, and an int that says how to go to this table concerns one of them, so the alias. In the ints, the alias is case sensitive even without quotes. That can be tricky. You just have to know it. The easiest is that if you explain and see the execution plan, the alias is there. We will see an example of that. So just take it. If it is quoted, use the quote. If it is case sensitive, just copy paste and then you have it. And we will see also examples. There are ints that have a list of aliases. When there is a list like that, there is no order. Those two ints are the same. And we will see how you do when you want a different order when joining tables. Basically, if you want an order in the aliases you pass to an int, then you will have nested quotes. And this is where it can start to be tricky. If there is something, a mistake in the int, or I said that you reference tables with the aliases, but some ints can reference an index. For example, for this table, for this alias, you want to go for an index. If you make a mistake, a typo in the index name, the int will be ignored. So this is an example where I force an index with its name, but the index doesn't exist. And then it's not used. It's not an index scan. You have a clue that it is not used because the cost, it chooses a sequential scan, but with a very high cost. Because what the int does, it says everything else than this index has the highest cost, so that it is not used. But if the index is not there, the query planner still has to come with a plan. This is the same with the right name, or just not naming the index, just saying for this table, use an index, whatever you want, and you can see that there is an index, just not the same name as before. I can also, without int, have this index. What I want to show there is that it is worse to have an int with a mistake than no int at all. Because here, even because the index doesn't exist, it's used no index at all, even the index that exists. So be careful when you name indexes, but also keep in mind that someone can rename your index. This doesn't matter for SQL, but this will matter for ints. Means that if you use an index name in an int, that can be okay for short-term workaround, but probably not for long-term. Because this is tricky, there are also ways to get more information about ints that are used or not. So by default, if there is a syntax error in the int, you get an info message. You can get more by setting the debug to verbose, and then you can also put the message either in the log or in the client message. So this is something that you can do. Either you want all the messages in higher level, or you just leave them and show the log in the session when you troubleshoot. We will see that in the demo. Very important to understand what an int does, and we had a clue before with the bad name on the index. An int doesn't tell the optimizer to do something, doesn't force anything. The int just sets a high cost on something else than what you want. We have seen that using the index int sets a high cost on sequential scan. And you can see that in the pgin plan code. The disabling something is a very high cost simply, which means that if the int cannot be used, another plan may be there, but you will see a very high cost. Okay, do you have questions? I have a few demos, especially to show how it can be tricky with the join order. Let me just get the demo screen maximized. Okay, and Everybody can read it, or should I increase the font? That's fine. Perfect. Okay. So here I'm connected to Yugabyte, but the same as Postgres. PG plan is there because of it is loaded. And now I will create just 3 tables to show what happens with joins. When you start to join 3 tables, the order of the join matters, and this is what I want to show you. Okay, let me just put that a bit smaller. So on the bottom, those are the commands that I'm running. On the top, you can see. I do an explain, select from C, joining to B, joining to A. And I've put funny aliases. So I'm joining cherry to banana to apple. Why not? Don't do that in production. It's just some fun. So without any int, the query planner comes with hash join, but starts with C, cherry, joins that to banana, and joins that to apple. And I want to change that for whatever reason. The most important int is the leading int. So you see, I put that just at the beginning. And I say, start with apple, then go to banana, then go to cherry. And let's see if the query planner will use my int or not. So I wanted apple to banana to cherry, but it is doing banana to apple to cherry. And the reason is that my int was used. First, it considered the join from apple to banana, but still has the possibility to do it in the other way, hashing one or the other. So my int was used. It is enough to get the query planner look at the aliases in this order, but the direction of the join, I didn't int that. Even if I mention something like that, I want a hash join between apple and banana, I still have a hash join between apple and banana, but starting with banana. Because as I said before, just mentioning the aliases there, the order doesn't matter. Internally, it takes the alphabetical order. If I went exactly to start with apple, join to banana, and then the result join to cherry, I have to put nested parentheses. So this means join apple to banana, and then the result join to cherry. And with that, you can see that it started with apple, went to banana, and then to cherry. This one just says, when you join apple and banana, do a hash join, whatever the direction is. So here it is the case. Now let's say that I also want a hash join for this one. So the result from apple to banana, join to cherry. I want a hash join. I just add this one with the list of the previous tables. When you join apple, banana, and cherry, then do a hash join. So if I run that, I have the kind of plan that I wanted, hash join, and the right order. And here, with those many ints, I really start to force exactly the plan I want for the joins. But the query planner still has the choice for each table to choose an index access or a sequential scan. I can also force that. For example, here, going to banana was a sequential scan. Now I will add the int index only scan for this one, which means that I have the same plan in the same order, but no index because I didn't create the index. Of course, if you force an index but there is no possible index, it will not use an index. Now running the same, I have index-only scan. Of course, if index-only scan was not possible, could not be used, here I have created an index that includes all the columns I have, and then it can be an index-only scan. So if I want to completely force the execution plan, I can mention all joins, all join methods, and for each table, how to access it, sequential scan, index scan, or sequential scan for the other. With those, I have fully entered my query, which means that, for example, if I'm opening a bug for the query planner and want to show exactly how to reproduce the plan, I can put all those hints, and I know that the one that will try on this database the same query will get exactly the same plan. So you can really reproduce a bug, for example, with that. Okay, I'm going back to the slides. Do you have any questions for the moment? Those are the most important to start, and then I have a few more things that are interesting to know. But the most important is probably this one about the joins, because if you do not use the right number of parentheses, then the query planner still has the possibility to choose something else. And the risk is that you put a few hints, but not enough. And you see the plan, and it is okay. It is the plan that you want, by luck. And one day in production, some statistic will change, and the query planner can still choose another plan, and this is not probably what you want. So, how to be sure that you have exactly the right number of hints, and in the leading, the right number of nested parentheses. If you have n aliases in your query, in my demo it was 3, then you need at least n-1 pairs in the leading. So I had 3 tables. I had one from apple to banana and another to the other one. For each of those pairs are a join, and then you have a join method that can be nested loop, hash join, or merge join. So those pairs, the first one will have 2 aliases, the second one will have 3 aliases. And then for each table, the access method, which can be sequential scan, a full table scan, an index scan, can be an index-only scan. You have also the possibility when you say index scan or index-only scan, without naming an index, it can choose any index. You can name an index. You can also use a regex for the index name. If you have a very clever naming convention, maybe you can use that. Which means that if you have put all your hints and you think that this fully forces the right plan, if you count all the opening parentheses or the closing, because of course they match, with n aliases, you should find 6 times n-2 parentheses. A way to check that you didn't miss anything. There is more that you can do with hints, and that are quite useful. First, you can change. So you know that the query planner, the most important information it is based on is the cardinality estimation. How many rows will come from this table after applying the filter? How many rows will come after a join? And there are statistics for that. If you analyze your table and you have good statistics and you join 2 or 3 tables, probably the estimation is okay. When you start to join many tables, an error will be multiplied, and you may find more misestimate in the statistics. And you can correct that, you can change that, and you have a rows int where you say when you join between A and B, whatever the estimation you think is the cardinality, just take this number. You force a number. And you can do better because forcing a number is not really nice. You can apply a factor. For example, you can say, when you join A, B, and C, if you come with an estimation, then just take 1/3 of it. And what can be the reason for that? There is something that the query planner doesn't know. It's the correlation between two tables. For example, if you have a table with for example, you have a table with cities, and you have a table with countries, and you select from it, you join for a specific city, country, Leuven, Belgium. What the optimizer will think is that it will look at how many countries and estimate the number of distinct value from it, how many cities, and estimate the same. But it doesn't know that Leuven is probably only in Belgium, or maybe in a few other countries. This information, you have it. The query planner doesn't have it. The query planner has statistics when you have this correlation within the same table, if you create extended statistics, but not between two tables. And this is where you can change that in the query. So you do not force a plan, you just give more information to the query planner about it. Maybe, how much time do I have? I didn't check, just tell me to see. I have a small demo about that. We still have time, huh? Yeah. Let me just check where I have a demo. I don't want to. Okay, the demo screen should see there. Here, I explain a join between my three tables and showing the estimated cardinalities from them. And now I will add this that says, when you join cherry with banana, just multiply by 999, and same there, and fix a number for this join. So I fix many things, I run that, and if I see the cost, you can see that the number of estimated rows has changed. It was 1 before, and now it is 666, because I forced the result of those join with that. Okay, and while I'm there, I will show you something else that I have in the next slides. And that can be interesting. If you don't use ints, there is a way where you can not force the everything, but at least the order of the tables that are taken. If you set join collapse limit to 1, you will restrict the optimizer to look at the tables in the same order as in the from clause. So if I set this to 1, it will not try to start with table C, for example. So here it will look at apple, then banana, then cherry, and it is doing apple, banana, and then cherry. And so that's a parameter. I've set it local for the transaction. You can set query planner parameters for the whole cluster, for one database, for one user, for your session, or with set local for a transaction. But without pgin plan, you cannot set a parameter only for one query. With pgin plan, you can do it with the set int. For example, here, for this query, I set join collapse limit. I also disable hash joins, all hash joins. So with ints, I can really choose the join algorithm. But if I just want to disable hash join for this query, I just put the set int like that. And I have only nested loops. So that can be also quite useful when you want to set a parameter and don't take the risk of setting it back to the previous value. You can set it for one query only. Let me go back to the slides, and I have a slide about it. Yeah, setting a parameter at query level. And the same example. The big advantage is that you don't have to set it back. Without that, you need to set local, run your query, and set it back. Be careful. You can use that for any parameter. You will not have errors, but those parameters are set only during planning time. So there are many parameters which will not change everything. For example, enable hash join, that's a parameter for the query planner. But if you set, I don't know, work memory or things that are used at execution time, they will not be used. How pgin plan works is that there is a hook. Before planning, it sets the parameter. After planning, it sets it back. But the execution will not see what you have set that. Okay, and so all that is quite nice when you can do it in the query. And most of the time, I use pgin plan just to understand an execution plan, do a kind of what if this index is used or not. So I do that interactively, and it's quite easy to put that like that. In some rare cases, you want to add ints in the queries that you will run in production, because, for example, you have there is a bug somewhere or bad statistics or anything, and you just want to run this query with this int. If you either you change the code and you add the int in the query, but if you cannot, because you don't have access to the code, because it's an application where you don't have access to the query, pgin plan has the possibility of setting the ints outside. You put in a table the query you want to int, the SQL text, and the ints you want to apply, and automatically the planner will look at it and apply the int. To do that, you need to create the extension. So for what I've done before, you don't need the create extension because you don't need any objects, just having pgin plan in the shared preload libraries. For this table, you create the extension, and then you have in plan int table. And in this table, let me just show you, or maybe I will show it later. So in this table, I have the columns there, no problem. You have the query, an application name, because you can set the application name and then use the int for one or the other. For example, you may want to int a query when you are in reporting mode, not for OLTP, and the ints that you want to put. So this is my example where I put my statement there, and I will explain the parameters and the ints that I want to apply, which means that when the query planner has to plan an execution plan for this kind of query, it will apply the leading int like this automatically for all of them. And to use it, you need to enable that. It's not enabled by default. So parameters, there are two kinds of placeholders when you add a query there. The first one is that if you use prepared statement and you have parameters in your query, of course, you put them here. But if you have a query with literal values, numbers, strings, you don't want to add an entry for all the possibilities. So pidgin plan has a placeholder as a question mark that you can add. So finally, you need to be careful about what you put. Also, do not put a semicolon at the end. Pidgin plan will really just replace literals by question marks and compare that and do no other magic. If you forget a space, if anything is different, something is uppercase, lowercase, the int will not be used. So if you go this way, test it also to be sure that your int is used and that this is really a workaround for a problem that you have in production. The goal is not to fix the plan. Even if you may find it a good idea, this tool is not sufficient to fix all execution plan for your application. But the critical ones, maybe. Okay, do you have any questions? I see that we have plenty of time. Do you have any question? Yeah? Yeah. Yeah. So you see some information, and I can show you by default. For example, if I set something, do you see it? Yeah. For example, here, if I put something that is not an int, I have the info message, syntax error. If I put something that is an acceptable int, but let's say I put a parameter that doesn't exist, I have also a message. So I have some messages, and I also, if I go back to the slides, or maybe slash, just checking, yeah. If you want more details, you can set it as detailed. So you will have more detail in the logs, and I will show the log message in the client. And then if I use int, that works. So this one was okay, I think. I have additional information there. So debug, that can help also really if you have question, it is used or not. So those are the debug log from the pidgin plan that tells you basically what is used, what is recognized. And so does it answer the question, or yeah? Yeah. For a missing index, let me check, because we added, if I remove this index, the easiest is to look at the cost. But here I drop the index, and I have a query there that names an index. Sorry, it was not this one. I had a query that names an index. Okay, I don't have the example there, but we will do it. Sorry, that's not what I wanted to do. Just wanted to zoom. So the index, I will put a name that doesn't exist and see what we have. So that's a name of an index that doesn't exist. And we don't have a lot of information there because at that time, yeah, we have not used one. But to be clear, the best is really to look at the cost, because in that case, if I have the cost, I can see very high costs. So this is how you see that your int, the int was taken, just putting a high cost for the non-index access path, but finally you have it. So yeah, you need both the messages and the high cost of it. If you see a very high cost like that, it's really that something is disabled, either with a parameter or not. Yeah. Okay, any more question? Yeah, that's a really good question. Can you integrate in Create View? Not as far as I know, and yeah, that could be very useful. As far as I know, you cannot. If you have views, the rewriter will rewrite it. So if you want to int something that calls views, you can use the int in your query with the aliases that are in the view definition, but you cannot create views. For example, what you may want to do is int an access path only for a specific join that is used by many queries, and you don't want to add all the queries in PG implant table. And no, that's something that's quite missing in this case. Yeah. And yeah, that's really not easy to work around. Maybe if you don't use views but functions, maybe you can put it in functions. But yeah, depends. Any more question? Yeah. Yeah, that's a really, really good remark. Ints usually are short term. You want to investigate something, maybe you have a workaround, but they are short term because the data change, the query changes, but also you will upgrade and the query planner will do something different. So yeah, my recommendation would be take ints only as short term and document them. If you had to fix something quickly, document it. You can also put comments after the int. The int itself is in the comment, but you can put another comment later. And at least look at it later when you upgrade, even when you patch something, maybe the behavior will be different. It can be really dangerous to accumulate ints. I've seen that not a lot in Postgres because this extension is not used a lot, but I've seen that a lot in Oracle where you have ints and where people just add ints as they come and they have the right execution plan. And when doing consulting, I've also optimized things just by removing ints that were there for 20 years because not accurate anymore. So yeah, be careful. The goal of SQL is that you shouldn't do more than describing the result you want and providing the right indexes and the right statistics. Ints are for the corner cases of that. Yeah, so be careful and document it. But the same for indexes. If you create an index, document the reason. Was this for one specific query? Was this for one specific use case? Because everything can change later. Yeah. Any more question? Who already used PG in plan at least once? Okay, so nobody. Who will do it? Cool. So that's really nice. Yeah. The main goal is to understand the query planner. If you want to understand why the query planner comes with a join method, for example, the first thing I want to do, if I think that another join method is better, the first thing I want to do is test it, because maybe I'm wrong. In many cases, the query planner is quite good, especially if you have many tables. Maybe what you think is not how it really works. So the first thing is to test it exactly. And then either you will realize that you need to gather statistics, add an index, or maybe you have a bug in the query planner, and even if it's a bug in the query planner, you will not wait to have a patch and apply the patch, so you will need to work around that in production probably, and this is where PG in plant can be used. In Yugabyte, we use also that a lot because it is distributed, so the access to the table may involve network calls, which is even worse. Doing a nested loop on too many rows, for example, doing a nested loop if you have 1 million rows from the outer table, it's already bad in Postgres. If you add network calls on it, it's even worse. So that's also a reason why we have it installed by default. But it's always helpful when you ask a user to test something, just give the ratings and they just test and give you the execution plan. Yeah, one more question? Yeah, the question is, are there negative ints? And yes, there are. Maybe I can show the PG in plan, PG int plan GitHub. So the small documentation that exists. Not easy to see that. I suppose it's there. And you have the list of ints. There are many ints that just start with no. And for example, no sexcan will use I don't see on the screen, but probably everything is there. So the ints that you can use, and yeah, you can do that. For the indexes, you need to take care that if you say index only scan, and index only scan is not possible, but index scan is possible, then it will not fall back to this one. So be precise on that. Yeah. Okay. So if you want more, I have a few blog posts about it, and do not hesitate to contact me. I'm a lot on Twitter. I'm easy to find on LinkedIn, on all that. And I'm also interested by your feedback about that. If you find, those are all the pitfalls I've found. Maybe there are more. So if you think that an int was not used, I'm also interested to know if there is something else that has changed on it. Okay. Thank you very much.